Section 3.2 is about whether or not compound statements are true or false, and one way of organizing all the possibilities is called a truth table. There are some basic building blocks that you really need to understand. So let's first talk about AND statements or conjunctions. AND statements are combinations of simple statements like the P and Q example in front of you, and here would be an example of an AND statement. You earned an A on the exam, and I gave you $20. For this compound statement to be true, for a compound statement that is connected with an AND, it's called a conjunction, for it to be true, both of the simple statements have to be true. If there's three of them, all three of them have to be true. If I make a statement that this is so, and this is so, and this is so, and this is so, then all four of those things have to be true for this to be true. If either one of these is false, then the AND statement itself is false. So the only way this statement right here can be true is if in fact you earned an A on the exam and if in fact I gave you $20. If both of those things are true, the AND statement's true, otherwise it's false. Well, that is something you have to memorize about AND statements. Memorize that they're very seldom true. The only way they can be true is if all the separate parts are true. Please remember that. Now, how do we put that in a truth table? Well, we take our statements P and Q, and you might as well learn to take them in alphabetical order. And we want to write down all the possibilities of true and false. And one easy way to do that is for the first statement, P, always let it be your first statement. Put true, true, false, false. Now you might wonder why in the heck we're putting two trues and two falses. Because we want all the possible combinations of P and Q's truth. So for Q, we're going to start out with true, false, true, false. And that little pattern, true, true, false, false, true, false, true, false, gets all the possibilities. True, 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 false, false, true, false, false. And then we do whatever we want to do next. In this particular case, we're doing a conjunction, an AND statement, and the symbol for AND is this caret symbol. And so we will do P and Q. Now, if P and Q are both true, then as we said earlier, this is a true statement. This compound AND statement is true. But if any part of P and Q are false, then it's false. So here's a truth table for the statement P and Q. It is true when P and Q are both true, but it is false at all other times. This is kind of a summary of all the possible information in the truth table. Let's move to the next compound statement on our list. It's a disjunction or an OR statement. So I'm taking the same two simple statements P and Q and I'm connecting them with an OR. So you earned an A on the exam or I gave you $20. The question is, when is this kind of compound statement true? And an OR statement is true if either part of this is true. If there's any truth to this or both, it's true. The only way an OR statement can be false is if both parts are false. So it's pretty much an OR statement's true unless everything about it is false. So think about the truth table. We're starting with P and Q just like the last time. True, true, false, false, true, false, true, false. Same start. The start you will be asked for in any exam questions. But now if there's any truth to P or Q or both, it's true. So here there's some truth, here there's truth, this is the only one where there's no truth to it. So that's a false OR statement. This OR statement is false if in fact both P and Q are false. Otherwise, it's true. And so this is a summary of the truth of an OR statement. All right? So let's move on to a conditional, an if-then. So here we're still using our statements P and Q, the same ones, but now it's an if-then statement. And for the purposes of what we're about to say, I would like you to think of an if-then statement as a promise. Specifically, in this case, a promise from me to you. Although it is not true, I will not be handing out $20 bills, but consider it a promise. So the if-then statement, the way we combine P and Q into a conditional if-then statement is, if you earned an A on the exam, then I will give you $20. It's a promise. And it's a true promise unless I break it. So this if P then Q statement is only false when I break my promise. Otherwise, it's true. So, how can I break the promise? Well, let's go down to our truth table and let it help us organize our thoughts. So this first one says P is true and Q is true. That means it turns out after I've made this promise, after I've made this statement, it turns out that we find out that you earned an A, and we find out that I gave you $20. Those are both true. So did I keep my promise? Well, yeah. That one's pretty easy. Let's go to the next one. Here, P is true, Q is false. What does that mean? It means you earned an A on the exam, and then it means that I did not give you $20. Huh. That sounds like a broken promise. You lived up to the condition that needed to be met, but I didn't follow through with the consequence. So that's a broken promise, and a broken promise is a false statement. This is a way of understanding why some of these things are true and false. So now, those two, most students understand, and it's not too bad, and everybody's kind of happy about everything. But the next two are tough, and they're hard to remember, and they're hard to understand, and it makes people's heads hurt, and it gives logic a bad name. So, let's see what we're looking at here. This is another possibility. It could be that this P statement is false. In other words, you did not earn an A. But the Q statement's true. I gave you $20. Now think about that. You didn't earn an A, but I gave you $20. So the question is, did I break my promise? And the answer is no, I didn't break my promise, because I only promised the $20 if this condition was met. And you did not meet the condition, so I can do whatever I want. I'm free to give you 20 or not give you 20. And I've kept my word because my word only applied if you met the condition. So this is true because the promise is void. It's true in an empty sense. The promise was never triggered because you didn't meet the condition, so the promised action was never triggered. And this one's the same. There's lots of falseness here, but I didn't break my promise because you didn't earn the A and I didn't give you 20, and that sounds pretty reasonable. So the only way a conditional if-then statement can be false, the only way the promise can be broken, is if the condition is met, that first statement's true, but the promised consequence, the implied consequence, is not followed. So true, false is the only way a conditional statement can be false. One other thing is, this symbol for if-then, it can be read implies. P implies Q. Earning an A on the exam implies that I will give you $20. That helps some people process this idea. The last basic compound statement we need to look at is a negation. A negation usually uses this symbol right here. And let's say we have the beginnings of a truth table, and we still have our same two statements. And let's say we want to do the negation of the statement P. The negation of the statement P, in effect, makes P false whenever makes a false statement whenever P was true, and a true statement whenever P was false. So if P is true, true, false, false, the negation is false, false, true, true. It's kind of like taking the opposite of a number. And the negation of the negation is the thing itself, kind of like the opposite of 2 is still 2. If we were to do the negation of Q, Q is going true, false, so the negation would go false, true, true. Often on simple statements, the way to write out the negation is to put in the word not carefully and correctly. So you earned an A on the exam. One way of negating that would be to say you did not earn an A on the exam. To negate the statement Q, I gave you $20. One way to negate it would be to say I did not give you $20. The only trick in negating things is when you're negating something like all, a statement that has all in it, or a statement that has none in it, or a statement that has some in it. When you're negating these kinds of statements that are talking about parts of quantities like all of something or none of something or some of something, those are very, very tricky, and our book does an outstanding job of describing this trickiness and listing this trickiness on page 93, especially the little chart there in the middle of page 93. So I strongly encourage you to read page 93. It would be a good idea to do that. So here's a compound statement. You did not earn an A on the exam, or I gave you $20. And let's build a truth table to analyze when this statement will be true and when it will be false. The first thing is to take this and put it in symbolic form. The or will be this guy eventually, but you did not earn an A on the exam. That's not P, that's the negation of P. Or, and then I gave you $20, that is Q. So we want the negation of P or Q in our truth table. Our truth table with two statements always starts out this way. Always, always. I'm going to say a few more alwayses just to be annoying, but really always. And then we have to head for this statement. That one's going to be our final one. I'm going to write it down over here, hopefully far enough away. Now we've got a Q already. It's right here. But we need a not P in order to do this statement. So let's put in a not P, a negation of P. If P is true, true, false, false, then the negation of P will be false, false, true, true. Now what we're going to do is we're going to head for this statement. I didn't need all this extra empty space because I didn't need any more statements. I'm ready for this. I want to combine these two with an or. This first one is right here, and this second one is right here. So I'm looking at the true falses here in this second column and here in this third column, and I'm doing an or on them. Do you remember the basic idea of or? The basic idea of or is that it's almost always true. It's only false when both parts are false. So here it would be false, and everywhere else it would be true. So this compound statement has a truth table that leads to this result. It's true in case 1, 3, and 4, but it's false in this second case.